I recently made a video where I talked a lot about how to choose your U in a U substitution problem. If you want to check that out, go ahead and click up there. But in this video, I'm going to be showing you how to finish the problem that I started in that other video. So this problem that we're going to be going over is basically where we're going to be picking it up is that we've already figured out what our U is going to be. And so we're essentially integrating this function by U substitution with a given substitution. So it's kind of similar to that kind of problem. Now this does come from my live stream that I did recently. I'm doing a live stream every Monday night at 5 o'clock Pacific, and I thought you'd find this problem pretty helpful. So I wanted to show you that portion of that live stream. But be sure to hit that subscribe button down below and the bell icon as well so you're notified of all my new videos, including when I'm going live, so that you can join us for the next live stream and hopefully get some of your questions answered. Well, anyway, let's go ahead and jump into the example and I'll show you how to finish this problem up using U substitution. Now that we've decided what we want to make our U, we can actually go about applying this substitution and integrating to figure out what the integral actually is. So like we did in the last example, once we figure out what our U is, what we want to do then is figure out du, which is just going to be the derivative of u. So the derivative of this thing. Well, like we already figured out, the derivative of z cubed plus 1, we can just use the power rule. It's going to be 3z squared, and the derivative of the 1 is 0. So it's just going to be 3z squared. So then what we also need to do is put on a dz here. So whenever you do this step here where you go from u to du, you want to tack on a d of whatever your variable is. In this case, our variable is z. We'll put on a dz there. It may be dx or dt or whatever the case is. So now we can take this equation, the du equation, and solve for dz, because dz is going to be the thing that we're going to need to substitute in there. Well, to do that, we just have to divide both sides by 3z squared, and we would just get dz equals du over 3z squared. Okay, so now what we want to do is we want to take these two pieces here, what u equals and what dz equals, and just plug those into this function over here. So we can see on our denominator here, we have this z cubed plus 1, which is the entire u. So we can just replace our denominator with u. And then we have this dz here, which we know is equal to du over 3z squared. So we can replace dz with du over 3z squared. Now we still have a z squared on the numerator. And there isn't going to be a nice way that we can figure out what dz, or I'm sorry, there isn't going to be a nice way that we can figure out what z squared is in terms of u. So what we want to kind of think about is, well, that might be okay, is what I'm getting at, depending on how this is going to simplify based on our dz term. And we can see, since we have a z squared on the numerator here, times this other fraction with a z squared on the denominator, those z's actually will cancel out. So what we actually have here is the integral of du over 3u, which really is the same as 1 over 3u times du. So really this is the function that we're integrating. We're going to integrate with respect to u of 1 over 3u. Well, to do that, first of all, what we want to do is we can pull out this constant 1/3, and we're just integrating 1 over u with respect to u now, which is a fairly straightforward integral. And this is actually one of the integrals on my integral calculus cheat sheet, or my calculus 2 study guide. If you haven't checked that out yet, there is a link down in the description where you can get more info on that, and in the pinned comment below as well. But the integral of 1 over u is natural log of u. So this integral here is just ln of u. We still have our constant 1/3 out front. And then we also do want to add in a plus c. And now the thing that we still need to do, there is a little bit more to do here, because what we've done is we've just integrated with respect to u. We've basically just converted this problem into some new variable, which we just made up, right? The original function was in terms of z. We basically just made up a new variable u and plugged it in there and integrated, which is great because it made the integration a lot easier. However, 1/3 ln of u plus c makes absolutely no sense in terms of the original problem we were given that only had z's in it. The u we just kind of artificially put in there to make our integration easier. So what we need to do now is undo that or reverse that process, which basically just means that we want to go back to the original u that we decided and plug that back into the function that we've ended up with now. So we need to replace anywhere we see a u with z cubed plus 1. So if we go back here, we want to replace our u with z cubed plus 1. And now this is going to be the integral of the original function that we were trying to find the antiderivative of. Like I said, that problem came from one of my weekly live streams that I'm doing every Monday night at 5 Pacific, 8 Eastern. Be sure to hit that subscribe button and that bell icon down below so you're notified when I'm going live each week, and you can come join and get your questions answered live, you know, whether it's about what we're talking about or not. I'd love to see you there. And if you found this video helpful, please be sure to hit that like button down below so we can keep spreading this out to more people and growing the Jake's Math Lessons community. Thanks, and hope to see you on Monday night.